We all have to do with them in practice and in theory, but what are forces anyway? What types are there and how are they displayed? We will explain this and much more in our new video series, Introduction to Structural Design. The aim of this video series is to build up basic knowledge of civil engineering and to further deepen existing knowledge. My name is Praxitelis and this video is about forces and loads. What is a force? In classical physics, this is an action that can accelerate or deform a body. You cannot see the forces themselves, but you can recognize them by their effects. The well-known formula for this is force equals mass times acceleration and the unit in SI is Newton. A good guide value is, for example, a well-trained construction worker with a weight of 100 kilograms, who causes a force of 1 kilonewton due to the acceleration of gravity. We engineers consider forces to be somewhat simplified because our calculations are usually idealized. Forces that act permanently or only sometimes on a structure, such as the self-weight of the structure, wind, snow, or even vehicles are called loads. We can divide these into the following types, depending on the target surface. Single loads. These are forces applied at specific points by an arrow indicating the direction and the point of application, such as the load transfer of a column to a foundation. Line loads. These are forces distributed over a certain length, indicated by a series of arrows, such as non-load-bearing walls. And forces distributed over a certain surface are symbolized by a surface of arrows, such as the floor structure of a floor slab. These are called surface loads. You can find the resulting concentrated load from line loads and surface loads by multiplying it by the respective length or area. However, there are not only constant line or surface loads. Trapezoidal or triangular loads are also very common in structural design. For example, by the load distribution of a floor. Point loads and line loads do not really exist, because all structural components or bodies have an action surface, albeit a very small one. Simplifying and on the safe side, we do not consider them as surface loads, but idealize them. In the practical implementation in the structural analysis software RFEM, it looks something like this. First, we select the desired load case in which we want to enter our loads. A single load corresponds to a nodal load in RFEM, so we simply click the node where we want to apply the load. Then we select New Nodal Load and enter our load parameters. To enter a line load, we have to differentiate between line loads and member loads in RFEM. If we want to apply the load to a surface that is surrounded by lines or on which lines are located, we use line loads. For beam structures, we use member loads instead of line loads. Finally, we enter a surface load. To do this, we click New Surface Load, enter our load size, and select our desired surface. We hope you enjoyed this video. If so, you can leave a like or comment. See you next time.